Hello and welcome back. Today we're going to get into topic 2, solids, liquids, and gases. We're focusing today on lesson 1, states of matter, and this should be on pages 46 to 54 of your textbook. Solids, liquids, and gases. So everything around you is made of matter. Matter exists in different forms depending on a variety of factors such as temperature. How does water exist in all three states of matter in this picture to the right? How many solids, liquids, and gases can you find in this picture? So label the solids with an S, liquids with L, and gases with a G. So we're going to label the snow as solid. You could also label the water around the edges as an S because usually when it is cold and that's where it freezes first. Obviously there's snow on the ground, so it is cold, but you can tell that that center there where the L is still liquid. So that would be an acceptable place to put that also. Now the G for gas you'd have to put up in the fog area where the water vapor is. So answering the question, how does water exist in all three states of matter in the picture to the right? So there are different kinds of environments that each thing is in. So the gas is in the air, it's evaporated water. The solids are on the ground and around the liquids. They're the edge of the lake around the liquid portion where it is starting to get cold, and so on and so forth. So now that we've labeled those, let's answer the question. During winter, you can sometimes ice skate outdoors on a frozen lake. Why can't you ice skate on a lake when it's not frozen? So here we are with a super simple connect it for the start of this week. You can skate on a frozen lake because it's solid ice. You cannot skate on a lake that is not frozen because it is a liquid. We are also going to go ahead and do the literary connection. So describe a solid, liquid, and a gas found outdoors where you live. You will need to answer this question independently. So a solid could be anything from the grass outside. That would technically be a solid. Liquids could be a propane tank if you have that in your yard, depending on where you live. And then gas could just be the oxygen and air, whatever you think, but you need to come up with your own answer. So you should not have the answers that I just gave you as yours. Come up with something unique and special to you in your home. Describing solids. So a solid has a definite shape and a definite volume. Remember that volume is the amount of space that matter fills. It's normally measured in cubic centimeters, cubic meters, milliliters, and liters. A book is another example of a solid. If you place the book in a different location, it will remain the same size and shape. So a ring of solid silver. The solid ring has a definite shape and volume. The particle arrangement in a solid, as you can see in this image, is very uniform. Everything's very tight, close, compacted. Everything's very tight together. All right, particles of a solid. So on the last slide, we saw that the particles that make up a solid, for example, the one in that solid ring, are packed very closely together. These particles are locked in a position so they cannot move around. They can, however, vibrate. Vibrate means that they move back and forth slightly. So let's do the academic vocabulary. Strings on a guitar vibrate to create sound waves that make music. Why does a cell phone vibrate? So I want you to go ahead and take a few minutes, pause the video, and come up with a reason that you think a cell phone vibrates. All right, so now hopefully you paused the video and you have your answer for your academic vocabulary. But a very good answer would be that a cell phone vibrates to alert the recipient that there's a phone call. That does not have to be exactly what you wrote down, but as long as what you wrote down is similar, that's perfect. Physical properties of solids. So not all solids are the same. Some are hard and brittle, while some are flexible. So are solids actually moving? Here we have figure 3 dancing in the crowd. So people at a packed concert don't move very far, but they're having fun. They're not standing still either. These people dancing in place are a lot like particles vibrating in a solid. Think about the motion of the particles in a solid and come up with your own way of describing them. So I want you to go ahead, pause the video, think about how you would describe the particles in a solid and describing them based on this. And then I will come back with the answer. So hopefully you paused and you can now write an answer, something similar to, they would be packed closely together and bouncing in place like a box full of vibrating cell phones. All right, so let's do comparing solids. So right here we have two solids, an eraser and quartz. So we need to write down the differences that you notice in shape, structure, and texture between the quartz and the eraser. So the quartz we noticed is hard, angular, pointy crystal, while the eraser is flexible, crumbly material that rubs off on other materials. But both are still solids. All right, so there are a couple different types of solids. We have crystalline solids, which are solids that are made up of crystals. These melt at distinct temperatures. Some examples are sugar, salt, and snow. And they are very uniform. As you can see in this image to the right, they are in very specific structures. It's very organized. It's the same over and over and over again. However, we also have amorphous solids, and these are particles that are not arranged in a particular pattern or a regular pattern. So these do not melt at a distinct temperature also. So examples of this include glass, rubber, and plastics. So our eraser example from before would be an amorphous solid. It would be rubber. And in the image of the particles, you can see that it is not regular. It's not the same every single time. There are different shapes throughout. All right, so crystalline and amorphous solids. A pat of butter is an amorphous solid. The particles that make up the butter are not arranged in a regular pattern. The sapphire gemstones are crystalline solids. Draw what you think the particles look like in a crystalline solid. Now, once you've drawn that, we're going to go ahead and do the reading check, and then we will check both of our answers. So, in your own words, explain the main differences between crystalline solids and amorphous solids. So go ahead and pause the video, give yourself time to draw the particles, draw what you think those look like, and then answer your reading check. And then I am going to go ahead and move on. So, hopefully now you have done so, you have your drawing. And we have the answer to our reading check, which is crystalline solids have particles that form a pattern, and they melt at a particular temperature. Amorphous solids get softer as they are heated and don't melt at a particular temperature. And then here's a picture of what our sapphire particle should look like. Fun fact, sapphire is actually my birthstone, and it is my favorite gemstone. All right, moving on to liquids. So describing liquids. Without a container, liquid would not have a definite shape. Liquid does have a definite volume, but no shape of its own. How could something not have a shape? What does this mean? And how do we find the volume of things that do not have a shape? So it doesn't have a shape, which means that it takes up whatever you put it in. So if we put it in a flower vase that's very thin and narrow, it'll look thin and narrow like the vase. If we put it in a low-lying bowl to put a couple plants, floating plants in, or floating candles for votives, it's going to look short and thin. The liquid is going to look like whatever it is, and whatever it is put in, sorry. And then in order to measure it, we have to use things like graduated cylinders, beakers, flasks, etc. In order to figure out what the volume actually is on that. So when the water spilled, what changed? Its shape or its volume. So we know that the volume is the amount, so 150 milliliters. They both have 150 milliliters, which means that its shape had to have changed. Particles of a liquid. So the particles in a liquid are always in contact with one another. They are packed almost as close as a solid, but the particles are not fixed in a liquid. The free-moving particles allow water to flow. Liquids are also called fluids. Fluids are a substance that flows, and that's because the particles are free to move. A liquid has no definite shape. So here to the left we have an image comparing the liquids to the very compact solids, and then also you see the gases, which we haven't quite touched on yet. All right, physical properties of liquids. There are two major characteristic properties of liquids. So there's surface tension, which is an inward force or pull among molecules in a liquid that brings the molecules on the surface closer together. And then there's viscosity, which is a resistance to flowing. So a low viscosity flows quicker, and a high viscosity flows very slow. So something with a low viscosity would be water, whereas syrup would be an example of something with a high viscosity. What are some liquids with a low viscosity? What are some liquids with a high viscosity? Like I just said, sorry, I forgot to read that before I told you. All right, so let's go ahead and do the reading check. Would honey be considered more viscous or less viscous than cranberry juice, and why? So, which flows more easily, honey or cranberry juice? And then use that information to write your answer. So go ahead and pause the video, answer your question, and then we'll go over the correct answer. Okay, so honey is going to be more viscous than cranberry juice because it flows more slowly than cranberry juice. Flowing more slowly means it has a higher viscosity. Describing gases. So like a liquid, a gas is fluid. It has particles that can move around one another. A gas has neither definite shape nor definite volume. Gas particles do not remain in contact with one another. So again, solid, hold shape, a fixed volume. Liquid, shape of container, free surface, and it does have a fixed volume. Gas is the shape of container and also the volume of the container. All right, particles of gas. If you could see the particles that make up a gas, you would see them moving in all directions. They're widely spaced and collide with one another as they fly about. When a gas is in a closed container, the gas particles move and spread apart to fill the container. So the gases that comprise Earth's atmosphere. So Earth has nitrogen, oxygen, argon, water vapor, carbon dioxide, and other miscellaneous gases. So nitrogen makes up the majority of that, and then the next most is oxygen. But they're all floating around in the atmosphere, sometimes bumping into each other, sometimes not, and just sharing all of that. Physical properties of gases. Because gas particles move and fill up the space available, the volume of a gas is the same as the volume of its container. For example, a large amount of helium gas can be compressed or pressed together tightly to fit into a metal tank. When you use the helium to fill balloons, it expands to fill mini balloons that have a total volume much greater than the volume of the tank. So here we have a model of that. So we see the gas going up into the balloon to fill it. The water is heated, which causes the air to expand and move up into that balloon, which is ultimately what's happening. Okay, so physical properties of gases. So volume of a gas, figure 10. The volume of a gas depends on its container. The helium gas in one small tank can fill 50 party balloons. And then here you have an example of the particle arrangement of a gas. So in figure 10, in general, the particles of a gas flow more easily than the particles of a liquid. So gases have lower viscosity than liquids. So let's go ahead and do our reading check. What are the main differences between gases and liquids? I'm going to pause. Well, I'm going to have you guys pause. I'm going to pause for like a second, which you'll need more time, obviously. So you guys go ahead and write down some of the differences that you can think of, and then I'll answer the question. All right, so liquids have a definite volume and shape, whereas gases do not. Gases expand to fill their containers. Gases have particles that are more spread out and not constant in and are not in constant contact with one another. So just clarifying what I said, liquids have a definite volume and they have a shape. They do not have a definite shape. They have a shape of whatever they come up, whatever they're inside, right? And then gases don't have a definite volume or shape. They take up their volume and shape or whatever the container they're in. All right, so that sums up our lesson 1. So we'll go ahead and do the lesson 1 check together. So what two properties of a gas depend on its container? So its shape and its volume. How do liquids with a high viscosity differ from liquids with a low viscosity? Liquids with a high viscosity move more slowly and are thicker than liquids with a low viscosity. What are the similarities and differences of the particle motion in solids and liquids? So both have particles that are always in contact. Solids have particles that are in fixed positions. They only vibrate in place. Liquid particles can slide past each other. All right, now how do particles in a liquid create surface tension? So the particles below the surface attract the ones above, creating a skin on the top of the liquid. Based on what you have learned, draw models of the particles in a solid, a liquid, and a gas. Use dots of particles and arrows to show motion. So your pictures, I'm just going to describe what your picture should look like, and then I will see them and grade them accordingly when it's time for me to look at your notebook, which will be tomorrow. So your solids are going to be uniformly packed particles vibrating in place. Your liquids are going to be closely packed particles flowing amongst one another. And your gases are going to be scattered rapidly moving particles. And with that, we're done with lesson 1.